Alright, we're going to be talking about inverse functions here. Key terms, a relation, and all a relation is when you have a domain and a range and the elements are paired. A special type of relation, which you probably know as a function, we've talked about that, that's where every input, every element of the domain has only one element of the range that it's connected with. Right? Every input has only one output. There are two types of functions, a one-to-one function. So we already know every input only has one output, but in a one-to-one function, every output also has only one input, and I'll show you down here. And for a many-to-one, some of the outputs had more than one input. So let's look at those. All right. So we come down here, and we can see this function. All right. Every single input has one output. All right. So this is a one-to-one function. And you notice something. When you do the inverse of a function, all you do is switch the domain and range, right? The range becomes the domain becomes the range, right? So this -3, it used to be 0, -3, and now it's -3, 0. Used to be 1, 2, now it's 2, 1, right? So what's nice about a one-to-one function, right, is the inverse is also a function. All right. Here's a many-to-one function. We know it's a many-to-one function because there is an output that has more than one input. And so when I reverse those, right, -4, -2 changes into -2, -4, right? 0, -3 changes into -3, 0. 1, 2 changes into 2, 1. But notice, since this was a many-to-one, right, I'm going to say many-to-one, when I do the inverse, when I switch my range and domain, it's not a function. Not a function. Alright, based on your conclusion above, what must be true about a function for its inverse to also be a function? It must be a one-to-one function. That's it. So an inverse relation is when you switch domain and range, but it is no longer a function. Alright, inverse function. Right? Still a function. Right? When I switch in, it's still a function. Alright, so I'm going to show you something else. And I think we're going to stop after I show you something else. Yeah, we are. So look. So, there's something I want you to see about a function, and here it is. Right? Let's change this. We're going to find the inverse of a function. You do that by switching x and y. So -4, -2 turns into -2, -4. 0, -3 turns into -3, 0. 1, 2 turns into 2, 1. 4, 1 turns into 1, 4. And we plot them. Look. This is -2, -4. Oh my goodness, that was the original one, 4, -2, and that's -2, 4. What do you notice? There seems to be some middle here. But let's do another one. -3, 0. -3, 0 is right here. I don't think 0 negative. Oh, -3, 0 is right here. There we go. And notice, there's the original over there. 2, 1. 2, 1's right here. So 1, 2 jumped over this line to 2, 1. Right? 1, 4. Let's do 1, 4. So here's 1. 1, 2, 3, 4. Look, 4, 1 jumped over the line to 1, 4. What are we noticing about the graph and its inverse? All right, on the line y equals x. That's y equals x right here. All right. The inverse is a reflection over y equals x. So if I folded this, all my points would match up if I folded along there. And that's your first page. Be right back.